All right, Game Engine Day 7. So we are continuing to go through the Magnum examples, kind of just trying out Magnum, trying to see how it works, see what the API looks like, see if I can break it in any way. Basically, just trying to make sure that this was a good choice for my sort of main framework. We went through the triangle example, the cube example, and I have the day off work, so I am going to be streaming for quite a while, I think. So I should be able to get through at least these next two, and then probably hopefully get into some other things that I wanted to try out also. Yep. So we've got our cube example, pretty cool. I guess I'll just go straight to the next tutorial here. So since this is going off of the triangle example, I think I'm actually going to just I'm just going to check out. Well, actually, let me reverse this commit so it'll get us back to the triangle. Why is it actually asking me for a commit message? That's not what I want. Well, that's fine. I can just reset to the commit above head. There we go. All right, so now we have reversed all of the changes that gave us the cube example. So now if we recompile here, we'll see, well, we need to compile first. But once we rebuild, we'll see we're back to the triangle example. Okay, so let's see what we've got. Custom shaders, this is going to be important. They're importing libraries and plugins. That's going to be pretty important, I think. Storing resources in the executable. Oh, that's actually interesting. I didn't realize it could do that. So that could be pretty cool. I'm actually really curious how they do that. Well, I guess we'll get there. Let's go back to the run this, and we're back to the triangle example. All right, so starting from that, we'll just go ahead and yoink all these. All right, and we're in main here. Similar to the original, custom shader and added GL texture 2D. Okay. So we need our texture. And instead of the vertex color shader, we're going to make our own shader here. And I'll just use the same name that they're using for now. Texture triangle shader. Okay. So starting with the shader, we've got vertex positions, texture coordinates, both two-dimensional. Declare both attributes as vector2, assign vertex position to location 0, and texture coordinates to location 1. Locations can be chosen arbitrarily, but location 0 should always be occupied. It's also good to make attribute declarations compatible between shaders so you can use a mesh configured for one shader with another shader. Yep. Next to these two attributes, it also needs a uniform for the base color and a texture binding. Good practice is to allow method chaining on them, which is what Magnum does. Seems reasonable. Okay, so let's make this file. What's it called? Textured triangle shader. .h. I'm going to use a pragma once instead of if-def include guards. I'll just copy this and walk through it line by line here. So our class is Textured Triangle Shader, inheriting from GL Abstract Shader Program. We're going to need to include this somewhere. Oh, they're doing it all. No, they're not doing it all in one file. Is this, let's figure out where this header is. Abstract Shader Program is this one. I really appreciate that they put the full pound include on there so I can just copy paste it really easily. It's the little things that make libraries nice to use. So we're inheriting from a GL Abstract Shader Program. We're defining some type defs for the attribute locations and their types, and then what they're called. Now I wonder if these names need to be consistent, like if the shader itself needs to rely on those names. Or if it just goes by attribute location. I'm not sure. I'm going to switch these to using statements because I find them easier to read. Oh, well. What is going on? There we go. I think I need to update the version of Emacs I have on my Windows PC, since I remember this that copy paste bug being a thing in an older version. So using position and using texture coordinates, and go ahead and line this up here. Now GL attribute we're probably also going to need to include, aren't we? Okay, vector 2 is going to be in GL math. Let's see what else. So we have an explicit constructor which is not defined yet. Do we define it in the example anywhere? Yes, we define it later. Okay, that's fine. Color 3 we're going to need to include. Okay. Copy pasting from that include things slightly annoying because it likes to pick up this other piece over here. So color vector 2. Set uniform, I'm guessing, is on this abstract shader program. Color uniform color. Color uniform we have declared down here as an int. So I'm wondering now, what do they have their own type defs for these things? equivalent to GLSL int. I don't know how I feel about using their own type defs, mainly because I wanted to have my own shortened, like, you know, this would be, int would be I32 or something. I was kind of thinking about doing that. They have more than just primitive types in here, though. And for compatibility, maybe I should just use it. Well, certainly, I guess from an API perspective, if they're, you know, if set uniform is expecting a Magnum int, then it's most correct to give it a Magnum int and not a, you know, my own type of int, even if they are equivalent. Oh, I do need to use a namespace Magnum in here. Generally, this is not good, especially using namespace inside of a header file. But since this is just an example, I'm going to do that. Definitely will not be doing that in the you know, when I'm writing code that I'm planning on keeping. Okay, so we're returning reference to this for method chaining. Set uniform, color uniform, which is the it's just a single int. I guess it's going to be packed into that. Set uniform color, uniform to color, or is that the like ID that we get? I'm not sure. Color uniform equals uniform location color. Okay, so it's an ID that OpenGL is giving us. So that's another thing that I'm not a big fan of. I'd rather use an explicit type def for those, just to distinguish the fact that it's not a traditional integer. It's an identifier from OpenGL that happens to be an integer, using an integer's storage, I guess. So just for explicitness, I would probably want to give this an alias of, you know, like uniform ID or GL ID maybe, or something like that. Before I would do that, I need to look into OpenGL's how they have defined their types, just to make sure I can give an appropriate name and such. So that's worth considering. Probably won't do that for this example, but I do want to think about these kind of things as we go. Okay, so let me go ahead and add this in here for clarity. So let's see. The color uniform is the uniform location of the color uniform. That'll be defined in the shader. And then we're setting a color 3 to that. Bind texture, given a GL texture to be. I notice this isn't const, which is interesting. Texture.bind. Okay, so it's actually the texture object knows how to bind itself to texture unit, which is this enum we have here, 0. What is 0? Texture unit. Set uniform location to texture unit. Okay, I think if I'm remembering my OpenGL correctly. I think that's basically, you can have multiple textures assigned, and you need to give each one of them a unique ID from 0 to 15 or something like that. And so we're just calling it texture unit because there's only one. This is another one where I would well, I guess this we're writing a custom shader and it only supports a single texture. So texture unit as a name, I think it does make sense there. We're forcing that the type of the enum be this int, Magnum int type. Which might help prevent some avoiding to need casting in certain spots, like when we're passing it in here. If it were to deduce a different type than int, we might have to cast it, but probably not. It would probably just implicitly convert. But probably not a bad idea to do that anyway. Switch over to C++ mode. I thought we were in C mode here. Okay, so on our shader, we can set a base color, we can bind a texture, and that's all we can do basically. All right, takes a vertex position and texture coordinates. We've declared them as attributes using these type defs here. And then we have two uniforms that we're passing down to the shader. The actual shader code, maybe I should say, the shader program. Okay. We store GLSL sources as compiled in resources because that's the most convenient way. By storing them in a string directly in the source, we would lose syntax highlighting and line numbering in case the GLSL compiler fails with an error, whereas storing them separate files, we would need to carry these along the executable. In the resource data will be compiled into the binary using CMake later. You can read more about compiling the sources in Karad's resource management tutorial. Actually, we'll go down this rabbit hole for just a bit because I'm really curious how they do this. So utility resource is a resource that can be compiled directly in. Karad add resource takes a resource configuration file and produces a C++ source file. Oh, I see. Source file is going to be passed among other source files to an executable or library. Interesting. So that makes sense as for text-based resources, since you can just throw them into a header file, with some generated ID or something like that. I guess for binary files you could do the same thing. Yeah, I mean, I don't see any reason why you couldn't do that. You could just write out the hex literals for every single byte, and then do that as a string literal. I think that would work. That's a pretty cool idea. File name, alias. And then you add it as a source also. Wow. Okay, that is pretty cool. I've put a very mild amount of thought into resource management, and I sort of pictured something like this, although not compiled in. I was picturing just alongside the binary. Um, but in terms of the interface, it would probably look similar. But to be able to compile it in definitely seems like a good idea. Well, let me think about that. So I'm thinking from the term of from the perspective of a game where you're distributing, ideally, a single executable would be awesome. And you don't want people to be able to go in and, well, maybe you do, but if you have the files alongside the binary, then people can modify them and mess with the game in various ways. For a game engine, does that also make sense? I mean, I guess you want this functionality to be available for users of the engine, but for the engine itself, there's probably not much benefit in baking in resources. Yeah, I don't think you want to bake any resources into the engine itself, probably. At least I can't think of any reasons why you'd want to do that off the top of my head. But you would want something like this to be available for users of the engine. So that's okay, pretty cool. Also not too complicated. All right, so let's see. So we're compiling in the actual shader, but representing it as a separate file, which is super convenient. In the constructor, we load the GLSL sources from compiled in resources, compile and attach them, and link the program together. Now that we explicitly check for compilation and link status, note that we explicitly check for compilation and link status, that's really good. Better to exit the program immediately instead of leaving it in some unexpected state. I would agree. It'd be nice if I could pre-compile the shaders as part of the C++ build as opposed to at runtime. I don't know if that's... I don't know exactly what that would look like, because how much of the shader logic is like tied to how it's being used versus the actual, like, just the syntax. I don't know. Theoretically, I think you could have a pre-processing step in the build where it just takes all of your shaders, tries to compile them, and link them, I guess. I'm speaking from I'm sort of making a lot of assumptions here because I haven't done that much with OpenGL shaders other than a couple small examples. I know at a very, very high level sort of how they work, but there's definitely some nuance I might not know. But I'm thinking that the shaders themselves, the actual shader programs, I would think could be compiled and linked without lots of surrounding context. But maybe that's wrong. I don't know. But something to think about definitely is it'd be cool if as part of the build, I could at least check for syntax errors and those sorts of things in shaders. It'd also be kind of cool if in my engine, if I had a live shader editor sort of thing where you could maybe you can edit the actual shader program and then tell it to recompile on the fly. That'd be pretty cool. Think about that. I'm thinking like I know I've seen, I don't know what engines do this, but there definitely are engines out there where you can basically all of your uniforms basically just get auto-generated GUI things in the engine, in the like the shader editor in the engine itself. So you can, let's say you could have a, for color, it could generate a color picker widget, and then you can edit it live and see how the shader changes as like it's live rendering the applying the shader to a model, something like that. So you can easily iterate on what the shaders look like. Same with like, let's say I just have some uniforms for, I don't know, just some parameters on the shader where like, maybe I have some, maybe like a spotlight or something, and I want to be able to change the size of the spotlight really easily. I can just drag a slider along, and it would update the shade, the running instance of the shader, I guess, live in the engine. That'd be really cool. Well, we're pretty far from that, but things to think about. Let's see where were we? So compile and link status is checked at runtime, and then it aborts if it fails. We then retrieve location for the base color uniform. Then we set the texture layer uniform to fixed value, so it doesn't have to be set manually when using the shader for rendering. I think that's just saying that it's always texture number 0, so you don't, the users of this textured triangle shader wouldn't need to care about that. I think that's what they're saying there. We require OpenGL 3.3 in the shader, so the attribute locations can be conveniently set directly in the shader source. Preferred workflow is to specify attribute location for vertex shader input attributes and fragment shader output attributes explicitly in the shader code, for example, that. Similarly, for output attributes, you can also specify blend equation color index for them. Okay. Now I wonder what, is there a way I can see like what kind of devices support OpenGL 3.3, for example? GeForce 8000 series or higher. Is that the really old? That's like before they even switched to the 3-numbered thing. Yeah, GeForce 8000. Okay, yeah, those are 2006. Okay, so OpenGL 3.3 has been around for a good amount of time. So that's not a big deal, I think. That was one thing when the last time I was messing with OpenGL and like trying to figure out extensions and like supported versions and all that. That seemed like a real pain of like, oh, of course you want the most compatibility, right? So you would set it to like a really low number, a really low OpenGL required version, but then you have to do all these like sorts of workarounds to, because you're just on a super old version of OpenGL. And I guess, I don't remember exactly why I decided to go with such a low compatibility. I think maybe SFML had some sort of compatibility requirements. I think that's what it was. Was was SFML was like locked to, I don't know, some old version of OpenGL because they were trying to be they were trying to have really good cross-platform support and support on old devices and stuff like that. So I was not able to use the new features that I wanted to because my OpenGL context was like too old. And then I tried, that's right. And I tried forcing it to use a newer context, and then SFML just completely blew up. So now I'm remembering all of that nightmare. Okay, so anyway, OpenGL 3.3, that makes me happy that I can actually use a newer version. I'm not forced into you know, whatever SFML was trying to do. Man, I had totally forgotten about what a pain that was. Okay, so we're setting the attribute locations in the shader source, and we'll get to the actual source in a bit. With newer OpenGL versions, we can also explicitly set uniform locations and texture layers itself. See uniform locations and these things. However, in this example, we'll keep compatibility with OpenGL 3.3. So I could actually, okay. Uniform locations, you can do the same thing with layout. And it looks like, so there's some sort of pragma here that the GLSL compiler checks, and I'm assuming that require causes it to basically just give up if we don't have this extension available. Okay, so we can set uniform locations directly in a newer version of, so 4.3 or GLSL ES 3.1, or anything with this extension, is how I'm reading that. Oh yeah, here we go. So, oh, actually, this is awesome. Actually, in Abstract Shader Program, it lists out for various features which version of OpenGL I need, or OpenGL ES I need, or whether it's supported in WebGL. That's also super convenient. Just to make sure that I'm maintaining the compatibility that I desire. That is actually something to think about too, is do I want the engine to support things such as WebGL or OpenGL ES? I'm trying to remember the difference between OpenGL versus OpenGL ES. I want to say ES was like, it's sort of the not, or it's, my association of it is with like sort of a lightweight OpenGL, so it's maybe for like phones or something. I am OpenGL for embedded systems. That's right. Embedded systems. Okay. Yeah. So yeah. Interesting. So yeah, that's something to consider as we go here. I'll have to think about that. Obviously, if I was was writing, if I was trying to write a super generic engine, then you want it to be as compatible as possible. But for my use case, I'm only targeting Windows and Linux PCs and not mobile, not web. So it's sort of, the question is it worth the trade-off of sort of the extra maintenance cost, the extra development cost of using the old support, while being more compatible, where in my case I'm not going to use the extra compatibility, but for sort of best practices, and if I ever wanted this to become something more real, then I would want it to be as compatible as possible. I don't know. Not going to worry about it now, but another thing to think about. And then same for the textures. It looks like if you have GL 4.2 or ES 3.1 for this extension, then you can specify the layouts for textures so that you don't need to do any kind of dynamic lookup. Although, I guess for the... Let me open that back up. Does that replace calling uniform location? Yes. I like how they say, they also give an example of if you can't, use the new thing, here's what you do in the old thing. That is, once again, really nice. Great for someone like myself who is approaching this with not a ton of OpenGL experience. Okay. So for this example, we're not going to explicitly set uniform locations and texture locations, because that would require us to support a newer, or require a newer version of OpenGL. So we're sticking with 3.3. And I've already mentioned something to think about once we get to real code. But for the example, we'll stick with this. So we assert that 3.3 is supported. Is there a different macro, I wonder, for OpenGL ES? Let's just see if I can find this in the docs here. So, oh, that's nice. So tab opens up the search here on the Magnum website. That'll be nice. So we've got Magnum assert GL version supported, Magnum assert GL extension supported. Not OpenGL ES. So I'm not sure how exactly that. Well, maybe you say like GL ES version or something. Let me see if. Oh man, this website. Now that I'm finding some of the shortcuts and stuff. Okay, yeah. So you'd say GLES as a different version, and you can assert that that is supported also. Okay, cool. All right. So now we're defining this resource, and this is actually going to be compiled in, if I understood that correctly, textured triangle data. So I'm assuming we're going to have to make some sort of config file with this as like a key group, textured triangle data. Okay. So this utility resource class wraps up a group of resources where the group name is this, and so it's going to load the whole group at once there. And then we use rs.get to pull out a single file. So this is the file name here. So I guess let's go back to this resource management thing. You can give them aliases, so I guess this is only used for lookup in the code, whereas this is the path. This probably must be the path on disk relative to whatever your build directory is, or your source directory. Yeah, here, so they say license.txt as the alias, but then it actually points to licenses/English. Okay. That seems useful. I could maybe see the aliases. Well, I guess, so in that example, they were showing how, you can just call it license.txt, but then you can have multiple licenses, maybe if you're compiling for different languages, for example. So that actually would be useful to use an alias there. That's interesting. I was just thinking that, maybe it would be, maybe the alias is not that useful because it's just an extra step of indirection, but in the case where you could maybe have multiple builds and you want different resources per build, then you would want to alias them in that case. Okay. All right, so we're loading this resource group, which is going to include the shader code as well as the texture file, but we haven't loaded that yet. So we're actually declaring shaders. This is okay, so I think this is probably an important distinction. A shader represents a single shader, I guess. I don't know what else you would call it. So like a single vertex shader or a single fragment shader compiled for a specific version, it looks like. And then the shader program combines those to be used in rendering. Which makes sense because you want the generally like your different shaders, your individual shaders will have some amount of communication between them. You're going to be passing some attributes down the pipeline. I guess that's what linking the shaders probably does. Okay, so I should probably be I should try to be clear with my language then, is shaders represent a specific, a single shader step in the pipeline, or something like that, whereas a shader program is the bundle of these compiled and linked together. And so you would use a shader program to render something. So it's already a little bit confusing since this thing is called textured triangle shader and not shader program. Maybe that's just a, you know, maybe people are used to talking about shaders meaning shader programs, and this is just a detail. I don't know. I don't really have a good feel for you know, I guess like industry standards for those sorts of that sort of like nomenclature. Okay, so we're declaring a vertex shader for a specific version of type vertex, and then a fragment shader. Adding a source. Now I wonder if this. Let me look up. I wonder if add source, if this resource get gives you the literal string, or if it gives you like a temporary file or something like that. I guess there's no. If you already have it in memory, why would you write it out to a temporary file? Add source string. Yeah, okay. And then add file, you can load it from a file. Okay, so you can do both forms through Magnum, so that's good. If I wanted to not use this Corad resource class, and I did want to put the files just on disk, or it maybe like in the actual editor. If I do something like a shader editor, maybe it would make sense to load them from disk and then only do this compiled in thing in an optimized build. Okay, so internal assert output. Okay, so I guess Corad maybe has its own documentation. But I'm assuming that compiles just returning a integer or Boolean or something. Compile. You can compile multiple at once. That's like this. Yeah, we're already doing that. You just pass a brace initializer list there. Compiles more than one at a time for improved performance. Cool. And then it returns a Boolean, which I'm assuming is just whether it succeeded or not. And presumably, if it fails to compile, there's a way to get at the compile error, which maybe this is what this macro does, but it's in Corad, so it's probably not. It probably doesn't know anything about OpenGL. That's interesting. So what? How do we get at the error when this fails to compile? Linker message is printed to error. Oh, so it just prints it. Okay. I guess that's fine. It'd be nice if I could actually get at the error string rather than just having it print to standard error. GL length status, GL info log length. Batched in a way that allows the driver to link multiple shaders simultaneously, i.e. multiple threads. That's nice. Yeah, it'd be nice if, if this just returned me the error as a string so that I could, that way I could, like, I could put it in my log, I could print it to the screen as a, big red error text or something. I could, if I decide to do a console, I could have put it in the console or something. In this case, I guess since it's, it's going to abort if it fails to compile, so it doesn't really matter where it ends up. So standard error is fine. That's something I probably would have done differently. So anyway, we're compiling and link. Well, first we're compiling both shaders, asserting that it succeeds. We're attaching them to, I guess, our shader program here. Then we're linking those all together, and then asserting that succeeds. Link is actually, so the shader compile is external here, but then link is part of abstract shader program itself, it seems. Yes. Yeah, so that's interesting. I guess you have to have this shader program object to be able to link them together, so that makes sense. Whereas individual shader pieces can be compiled standalone. Okay, so going back to my original question, question of can I do this as like a pre-processing step to sanity check my shaders? I think the answer is I can compile them with no context needed, because that's literally what it's doing here, right? Is we're loading the file and compiling it. It has no other context outside of that. And then if I wanted to sanity check linking, I would need to know a little bit more context in how they are combined into shader programs, which could be done, I think. I mean, basically that's what this is doing already, right? It's we're defining this resource that bundles these shader sources together and then linking them. So if the resource, if I always basically if all of my shader programs are available sort of standalone by themselves, then I could also pre-process them and sanity check that they compile, I think. Or rather that they compile and link. I can definitely compile them as a pre-step, but I could also link them together as long as I know the relationships between the different sources, which all will be defined in the C++, I think. Although that's actually an interesting question, which is, so going back to the very first stream I did, I said one of the goals of this engine was to be as data-driven as possible, meaning if I want to run a game built on this engine, all of the game logic should not require me to recompile the engine. In an ideal world, at least. I'm not sure how feasible that is in terms of like just because there's a lot of extra complexity that comes with that, and some things maybe just need to be compiled in. Like a lot of the graphic stuff I think would be very difficult to... Well, is that even true though? Because a lot of OpenGL stuff is calculated at runtime. There's basically no compile time OpenGL anything. And right now the main thing that we're sort of bundling in as part of the compilation process is this relationship between our individual shader sources, the resource thing, okay, yeah, so this kind of goes back to you don't want maybe to build your game, maybe you do want to be able to compile it. What am I trying to say? Like the sort of final product that you want is probably a single executable. So in that case, you do need to compile it in some way. But for iteration, you don't want to have to recompile every time you make a small change. So you want those to be flexible. And then you want to be able to compile things at the very end. So what I'm trying to get at is like how could I write this code? How could I define these shader programs? How could I define a custom shader program specifically in sort of user space without needing to recompile the entire engine? Or could I, is that even worth considering doing? Because of course I can, as part of the engine, I can define, you know, hundreds of shader program template sort of things where users fill in the blanks. So like I want textures, I want you know, positions, and Magnum seems to have tried to do some of that. But if I need to compile at some point, i.e. to produce the final output, does it make sense to maybe have certain things be compiled in? So maybe custom shaders would require a recompile. I guess I just don't know exactly what that looks like. What is it? What does it mean to, like, I have an engine and I'm building things on top of that engine. I'm defining sort of this flexible data, but then I also need to be able to recompile the engine itself. And how much of that is still bundled into the data and you're like doing the sort of resource thing where it's like you're just packing it in versus I'm actually changing the core code of the engine itself. I just don't know what that looks like exactly. Maybe another way to phrase it is like, do I do I say sort of the core of the engine is entirely rigid, and then maybe you have some sort of plug-in system where you can extend it and maybe even, maybe that even necessitates recompiling anyway, or maybe it's purely at runtime, but so maybe you just have to compile the plugin separately. I don't know. It's a sort of an architecture that I've never really had to think about before. I'll definitely have to think about that some more. Well, yeah. Let me get back to the example. That was a bit of a tangent that I didn't really want to. Probably shouldn't have spent so much time going into. We want the example here. Okay, so anyway, once we're done compiling, linking, and sort of creating our full shader program, we set up our uniforms. And the only difference between these two uniforms is that the texture unit is fixed. Well, I guess in both cases the uniform location is dynamic, but the texture needs both a uniform location and basically like a texture ID, a layer number. Color doesn't need that, but both of them do still have this dynamic uniform location. But for the texture, we just always have this texture object that we're holding on to. Or are we? Where does it? So that's another thing, is where does this texture live? Who owns this texture? Our shader doesn't own it, clearly. So it must be owned outside of the shader. Bind texture. Yeah, so the texture lives outside of the shader, but then we bind it to the shader before we render. I may think about if there's any maybe more automated way to handle that. Because you definitely, I think you don't want the shader to own the texture, because you could have multiple shaders that refer to the same texture. But maybe you have just hold on to a shared pointer or a weak pointer into like a resource manager class or something like that, where you load the texture ahead of time, and then when the shader is defined, it points into that. I guess, I don't know. I'll think about that too. There's definitely some questions around like what happens when you like load or unload textures, and or basically like what's the lifetime of textures compared to shaders? How do they overlap? Is there always a hierarchy of lifetimes? So that would probably determine the answer to that question, and I haven't really thought a whole lot about that yet. So that's interesting. Anyway, the color, we're setting the uniform directly. The texture, we're binding the texture, but the uniform is already set. So probably a important distinction there. Wow, okay. We're halfway through this example. I've been talking too much, I think. All right, so now we're getting to the actual shader programs themselves. The actual shader source files, maybe I should say. Let me just see how this is set up. It looks like it's assuming they're all in the same directory, so I will do that for now. Again, once we start to actually flesh some of this out, I think I would want shaders to go in their own directory. Well, there's definitely a couple different ways you could organize it. Do you have an explicit shaders directory? Do you maybe well, I guess you could reuse shaders in generic ways, so you wouldn't necessarily want to put shaders alongside the models that they're used with or anything like that. I think you would just want a shaders directory. Anyway, let us make this. Okay, so our vertex shader, copy, paste. Let me split here so we can take a look at how this is used in main. So not in main, but in the shader program class here. So position is our 0th attribute, and texture coordinates are our first attribute. So you can see position and texture coordinates. Position is a 4-dimensional vector, although we're saying that it's a 2-dimensional vector. Maybe I guess GL position is always a vec4, and I guess Magnum knows how to translate between a vector 2 and a vector 4. That's my guess. And then this is actually a vector 2, and that makes sense. We're saying that interpolated texture coordinates is our output of the vertex shader. That's a vector 2. And then this is an implicit output, which is the position of the vertex after being transformed. Now, since we're just doing a triangle in 2-dimensional space, we're actually not transforming it at all. So the position is purely in, what's it called? The universal device coordinates or something like that, where it's basically, I think it's like -1 on the left to 1 on the right, and -1 on the bottom to 1 on the top, maybe, something like that. Basically the direct things that we're setting here. So this is the top vertex? Nope. This is the top vertex. 0x, yes. 0x and 0.5y, so it is +1 toward the top of the screen and -1 toward the bottom of the screen. Yes, and then negative on the left, positive on the right. And then we're just setting the interpolated texture coordinates as texture coordinates. The distinction there is that there's this implicit interpolation of vertex attributes in between the vertex shader and the fragment shader. So basically, since we're only dealing with 3 vertices in this triangle, it interpolates for every other pixel inside the triangle um, what values to use. And I think there's like maybe different interpolation methods, because there's some nuance with like level of detail and perspective and stuff where you actually need to sample from like surrounding pixels and stuff or something like that. I don't exactly remember the details, but I think there's probably a couple different methods of doing this interpolation, but it's interesting that we need to explicitly set it to a different out variable like this. Because I feel like there was an in-out type. Maybe not. In-out? In-out? Oh, there's in-out on functions. But not on attributes. Uniform. Okay. Yeah. So there's no in-out attribute, I guess is what these are called. I'm not confident in that, but since there's no in-out, you actually have to have the input and the output, and you have to explicitly assign them like that. Okay, so we're telling the pipeline to interpolate our texture coordinates. So for every pixel, it'll know, based on the texture coordinates of the surrounding vertices, what coordinate to use. And we're setting the vertex position just to the raw position as input. So that's fairly straightforward. And then for the fragment shader, so we've got the color uniform with a default value, which I didn't realize you could do, but I guess that makes sense. So if we forget to set color, it will show up as all white. And then a sampler 2D for the texture. And that's where we get these uniform locations and save them off in our shader program so that we can update them later. We get the interpolated texture coordinates as an input from the vertex shader, and then we're outputting the final fragment color. Fragment color RGB equals color times texture data interpolated texture coordinates.rgb. And then we're setting alpha to 1, so there's no transparency. Right, so the OpenGL has this built-in texture function that takes our texture data that we've set up in slot 0, which is this one, which we've done by binding the texture to the shader. So it takes the texture data, it uses it basically as a lookup map based on the coordinates that you've given it. And this is going to be per pixel as interpolated by the pipeline. And we're taking only the RGB components of that, not the alpha component. And then multiplying by the base color so we can sort of shift the color of the texture, I guess. Especially if this was like a black and white texture, then you could, set this to any color that you want, and it would color all the whites appropriately. Basically, it is just a pure multiplication, and the math happens to work out that it, in effect, affects the output color in a certain way. It's hard to describe, but it's the same as if you open up Photoshop or something where you can change the color blending modes to be like add, multiply, divide. It's literally just math that it's doing there, where it's adding values together, it's multiplying values together, or something like that. It's all coming directly from math, where the values are all 0 to 1, so it scales out appropriately. Yeah, so all we're doing is we're setting the color of the pixel based on this texture lookup, and then scale that by our base color. Okay, built-in texture shader. Well, the main purpose of the example is to show how to create custom shaders. Please note there is a built-in equivalent of the above shader, flat 2D, with flag textured to get a textured version. Also contains setters for transformation matrices, which were omitted for this example. So you could use this for like 2D, like UI kind of things or sprites. This would be close to, this would what you would use if you wanted something like SFML style. You'd still want to wrap it up in some nice classes probably, but in order to get just 2D sprites on the screen, that's probably what you would use there. Setting up the mesh and the texture. Use vector 2 for both 2D vertex positions and 2D texture coordinates. Okay, so we're back in main now. Texture triangle example, still the default configuration here. I'll keep the clear color for the fun of it. So we're still using this triangle vertex struct, but instead of vertex colors, we're now changing it to texture coordinates. That's vector 2. I'll get rid of this log here. So then we're using the same shape of the triangle, but instead of colors, we are describing how to look up into our texture based on the which vertex we're at. So if I'm remembering correctly, the texture lookup is based on the upper left of the texture, or is it lower left? Based on this, it seems like it must be lower left because the lower left vertex is at 0, 0 in the texture. Unless this flips the texture vertically. Well, that's something that we can easily just experiment with. So we're going to do 1x, 0y for the lower right vertex, and then for the middle top, x is 0.5 in the texture and 1 in the y direction. Do it like that, maybe. Okay. So similar to the last example, we're creating our OpenGL buffer, setting the data based on our triangle mesh and texture data, and then we're assigning, well, what's a good way to describe this? We're actually moving this buffer that we just created into our mesh. So he now owns the buffer, and then we're also describing the shape of the buffer and how it should be interpreted. So I'm still going to do the same thing where we just get the size of the data dynamically. Move the buffer in. Start offset is still 0. And now here we are using our shader program's type defs. Okay, so that answers my question from earlier, which was, does abstract shader program care about these names? No. It's purely when you're setting up the buffers, you actually instantiate these attribute objects. So you can name these whatever you want, as long as it is clear what the relationship is between the actual structure that you're putting in the buffer versus how you describe it here versus how they're used in the shader itself. Okay. Okay. So now we're gonna load the texture, it looks like. TGA importer plugin. Plugin pump loaded, we exit immediately. Plugin directory locations, plugin loading and using plugins. Let's dig into this a little bit. So basically you opt in to certain file format importers as plugins so that you don't have to build all of them at once just because there's so many file formats. The plugins can be dynamically or statically loaded. You can change which plugins per platform. Useful. Additional plugins are available in the Magnum plugins repository. Oh, Magnum plugins. I just want to find the GitHub for this. Where is this? Magnum plugins. All right, is there a list? I just want to see a list of what they have. Okay. I guess this was when I had my initial list of comparison. I guess these were all basically plugin based that I had listed out. So that's fine. Okay. Okay, so the seems like the core concepts here are we've got the plugins themselves, we've got importers, we've got converters, and then we have some base types for each of the different types of things. So audio, font, image. Plugin dependencies. Dependency loading is done automatically. Magnum font plugin depends on TGA importer. So you have to create plugin managers for all the dependencies, it looks like. And then it's a single CMake option to turn on static plugins. Is there any reason to not just turn on static building of plugins? I mean, I guess it would probably... Would it increase compile times? I mean, I'm still going to have to build them anyway. Good for reducing memory consumption. Only because you can lazily load it. I guess that's true. But I mean, presumably, at least for a game, I'm already going to know ahead of time all of the file types that I need, and I'm probably going to be loading them throughout the lifetime of the application. Maybe that's not always true. Maybe I don't know, cutscenes or something. Videos I maybe am not loading all the time, so therefore no point in keeping the video loader plugin in memory the whole time. I guess I'm just thinking that I kind of tend to prefer static building everything if you don't need to worry about things like memory and such, just because it reduces the complexity of having to load things at runtime and all of the edge cases that sort of comes with. Just more opportunities for failure when you're trying to load things at runtime and oh, oops, I forgot to copy this DLL over or whatever. It's just way easier if it's all static. But I guess that does sort of rely on you. That works well in an environment where you don't care so much about hardware limitations. Yeah, pros and cons, I guess. Okay, well, we'll get to an example use case of plugin stuff here. I don't need to dig into all of the plugin usage. Okay, so we're setting up our plugin stuff here. And actually, I'd rather do this before we start setting up meshes and stuff. Just so that we can blow up even sooner if there is a problem. So we're creating a plugin manager that manages importers, I guess. That's how to read this. Let's go back to this thing just to plugin manager. For a given plugin interface. Containers pointer to abstract importer, which we get by asking the manager to load and instantiate the TGA importer plugin. I wonder why the manager needs this template here. Since we have to, I guess it can't get this type from the return type here. So you'd have to say like load and instantiate. You'd have to put it in the template here instead if you were to do that. But that would let you use a single manager for loading all the plugins. It's interesting that it has to be templated like that. Well, I guess it's not a big deal. So we're loading and instantiating our TGA importer, saving it off as this importer pointer. I wonder why we have this whole abstraction around a pointer. That I'm curious about. Okay, so I think Karad does have its own docs. How do I get back to that? Here we go. Pointer, containers pointer. Equivalent to unique pointer. Okay, so it's a smart pointer, actually. Unlike stood unique pointer, this class does not provide custom deleters, doesn't work with arrays, and doesn't have a constexpr API. Okay. Implicitly move convertible to and from a stood unique pointer, if you include this header. Okay. Now I'm trying to remember, is there... I know in C++ 17, I think, you can, if you're calling a constructor, or maybe it's even just function templates in general, where it can deduce the template arguments, you don't even need to explicitly put them. Does that work on variables also? I don't know. Like, could I just leave this off? I don't think so. Unless it's new in C++ 20. So we have our unique pointer to an importer interface. If it's null, then we'll exit immediately. And actually, instead of exiting, I'm going to throw an exception so that it's a little bit more clear if this does happen. Download TGA importer plugin. This is sort of my preferred way of using exceptions, is just as aborts with error messages and stack traces attached. You could make the argument that maybe this is not, well, this allows it to be caught, basically. Obviously, in this case, I'm basically already in main, so like nothing's going to catch it. But if you truly want to abort unconditionally, then you could argue that you don't want to give anybody the opportunity to catch this error and suppress it, but I would argue that that's pretty much always the up to the caller. Like, forcing abort from inside a library is just seems bad. Not that we're in a library in this case, so it doesn't actually matter. Does not apply here. Okay, so we're loading our plugin. Also stored as a resource. So this probably would look different if this was a more fleshed out example, but in this case the shader is the one loading these resources, or at least getting the strings for them. Really, that shouldn't be the shader program's responsibility. It should probably be passed in so that you could use it with any textures or any or wait, is that true? No, because this only is loading the shader source code and not the textures. That's right. So the client still loads the actual texture file. Yeah, so probably the way I would do it is this would be its own resource group, and this would be a separate resource group. Because the texture shader will work regardless of what texture you pass in, and you would want to be able to reuse it. But in this case, they're all part of the same group, so that's interesting. So now we're loading the texture. Similarly to shader sources, the texture is also stored as a resource in the executable. Yes. Do this after we set up the mesh. So we're loading the texture group, texture triangle data. We have our TGA importer. Let me actually rename that. TGA importer. Open data. rs get raw. Stone.tga. So I guess this is an example of a binary format. Open data. So I wonder if this TGA importer. I want to see what type this takes, just for my own curiosity. Abstract importer. Open data. An array view of const char. So similar to std span. No memory management. Cool. I really like, although it's wrapped a lot of its own things in, or rather, it's providing its own implementations for a lot of standard library things. That does allow it to, I think Magnum in its feature list said that it supports C++11 maybe. I don't know. Anyway, the it's certainly convenient from a compatibility perspective, and I like that they are. I'm getting the impression that they are using a lot of modern C++ paradigms, even if they're not using the most modern C++ compiler features. So, such as this, view types and like smart pointers and those kind of things. All a good sign. Okay, so we're opening data from our TGA importer, stone.tga. If it fails to load, we'll throw okay, after it's loaded, we create a texture from it. Note that we have to explicitly set all required texture parameters, otherwise the texture will be incomplete. GL texture format is a convenience utility that picks up certain texture formats or any other based on image's pixel format. GL texture format, image format. So the image knows its own texture format, and so that is a nice little convenience function. But otherwise, we do have to set all of these things on the texture. Okay. So I might end up needing to abstract some of this. Since this is kind of a lot to do every single time I use a texture, right? Okay, so they have an optional type in containers, so that's another more modern C++ thing, so that's good. Trade image data 2D, importer image 2D 0. And importer we renamed here. So does this mean that, I mean, I guess you could have a file format with multiple things bundled into it, and so maybe this is needed for this to really handle this in an abstract way. I wanted to go back to the TGA importer docs. Whoa. TGA, nope, TGA importer. Oh, maybe, yeah, I guess I did want the abstract importer. Image 2D internal importer state. Material data, animation data, camera data, image data. light data, mesh data, object data, scene data, skin data, texture data. Okay. Yeah, so importers can do tons of things. That's why this result is optional, because I guess maybe your importer doesn't support things of this type, but that means that you could have an importer that supports everything at once. So that's actually cool, because that means I could write my own proprietary file format, wrap it up in an importer plugin, and have it handle everything for every area of the game. So that's potentially pretty cool. Or you break it down into whatever makes sense for the engine. Like maybe I bundle all of the animation and skinning or transformations, those kind of things. Maybe you bundle those together, or you have like your particle system. Maybe it loads the textures plus the I don't know, whatever proprietary texture format. Well, I guess I guess I am limited by this abstract importer interface, so it would have to be one of these types that it's loading, right? Or my format could be composed of these types. So if I had my own custom resource that didn't fit into one of these descriptions, like maybe I don't know, some sort of script resource or something that doesn't really fall into any of these. So that wouldn't quite fit. Well, anyway. I wanted to see what the parameter on here is. ID and level. Image ID, MIP level. Okay, so it supports. Does MIP actually stand for something? I know the term MIP mapping, and it's basically just when you have multiple textures of like different resolutions, so that you can like render things that are farther away with a lower MIP level, so you're not wasting a bunch of processing time on things that where the detail doesn't matter. MIP map. MIP map. Does MIP letters MIP are the multum in parvo, much in little. Oh, that's cool. Yeah, here's an example where you've got the full-size texture and then just powers of 2 smaller, so that if something's really far away, you don't need the full resolution. Okay. What was it? Multum in parvo? Multum in parvo. Today I learned. Level equals 0. So anyway, yeah, if your image format supports MIP mapping, you could do that. And then if you have multiple textures bundled into a single file somehow, you can also do that. So assert that image is there. I wonder what this internal assert Like, why is there a distinction between an internal versus external, presumably, assert? I don't know why that is there. So we're setting the wrapping, GL sampler wrapping clamp to edge. Magnification filter, linear. Minification filter, linear. Okay. What type is this? Texture 2D. I'm now kind of curious about, if I close out my docs page here. Texture 2D. Which is just a texture. Minification filter, magnification filter. So you can generate bitmaps from textures if they're not already pre-generated, I guess. And then the texture object itself knows how to handle bitmap levels, so that's kind of cool. Minification filter. Bitmap filtering. If set to anything other than base, make sure textures for all MIP levels are set or call generate bitmap. Filter used when the object pixel size is smaller than the texture size. So you can do sampler filter. You can do nearest neighbor or linear interpolation. Magnification filter is when the object pixel size is larger than the largest texture size. When object pixel size is smaller than texture size. Object pixel size. Does that mean the size of the object in pixels? Yeah, that's what that means, because then it has to basically choose how to compress the texture's pixels to fit within the size of the object on screen. And same for this, where you have to choose how to expand the texture to fill the gaps. Okay. Interesting that they don't default these. What's this initial value? The tutorial said that you basically have to set every single one of these, otherwise it's incorrect. But I'm trying to figure out why they don't default some of these. Bitmap, magnification layer, wrapping, max anisotropy, anisotropy. I don't know how you anisotropic, anisotropic, anisotropic.
Anisotropic.
Anisotropic. Anisotropic. All right. Max anisotropy. Tropy. Anisotropy. Anisotropy. Storage, texture format, sub image. and then generate bitmap. Okay, so it definitely gives you a lot of control. I'm just not sure which of these are actually required. Default uses mipmaps. Be sure to either reduce mip level, explicitly allocate all mip levels, call generate mipmap after uploading the base level, or call set minification filter with another value to disable mip mapping. Sampler mipmap base. If set to anything else than base, make sure textures for all mip. Okay, so base disables mip mapping. So that's what we're doing here. Let me add a comment. No mip mapping. We had to still set wrapping. Initial value. Yeah, see, so it says initial value is repeat. So why does the example say that we have to set all of these parameters? Otherwise, the texture will be incomplete. That seems incorrect, if I'm reading this right. It won't be incomplete, it'll just maybe not be what we would prefer. I don't know. I might have to experiment with that to figure out exactly what it means here. But the way I'm interpreting this is you get some defaults like repeat and for the mipmap setting, what was it? Minification filter. Initial value is nearest neighbor for the filter and linear mipmap. So in this case, we do need to set this explicitly because we need to disable mipmapping. Like wrapping, I think we don't need to set. Let's just look at all these things that it's doing. Maybe magnification, I think, is. We probably have a default here. Initial value is linear. Set storage. Set storage. After calling this function, the texture is immutable, and calling set storage or set image is not allowed. Interesting. So this one we do have to set every time, it looks like. Set image, what's the difference between that and set storage? Set image data. Level texture format, image view. On platforms that support it, prefer to use set storage and set subimage. Better performance. Vector type for dimensions int, where dimensions is our texture dimensions. size, internal format. So we're saying there's one MIP level. Internal format is whatever the image loaded as. So whatever pixel format that is. Size of largest MIP level is the entire size. So if I'm interpreting this right, set image is the combination of setting the storage where you're actually setting up the sort of texture buffers, I guess, and then set some image you're blitting into that. And then set image is the combination of these two things, but is slightly less performant, but better supported. So this one requires GLES 3, WebGL 2, but it's deprecated. Set storage. And set subimage. Well, set subimage has the same requirements. OpenGL or desktop. Oh, so not WebGL, I guess. What is this? Requires OpenGL ES or desktop OpenGL, but then it has it says WebGL is also supported. So I guess this is not saying that it requires one of these two things. It's saying this is a special case for those things. In WebGL, the pixel type must match the original one. You might not be able to use set storage as it used implicit pixel type. Okay, we're getting a little bit in the weeds. Really what matters is the preferred way to do it is set storage followed by set subimage, I think. And this one is a required thing on the texture. Set subimage, set subimage level, MIP level, offset, and then basic image view. Offset where to put data in the texture. Image view, or image data of the same dimension count. Set subimage image. Okay. So that is a okay, I see. I think I see what's happening. So there is a distinction here between the texture object and the image object, where it looks like the texture does not own the image. So when we set storage, we're actually, I guess, setting up the buffers for. Does it actually copy over the image data, or is it? I guess the texture is in OpenGL land, whereas the image is in CPU land. So I think set subimage is what copies the data to the graphics card. Set storage, I think, is allocating the buffers in the GPU. I think that's how that works. I think that's how that works. Set subimage vector. offset is this empty vector, which I guess is probably 0, 0. Basic image view image. Then we're giving it the image, a reference to the image. If arbitrary state access is not available, texture is bound before operation if not already. I've seen this one in a couple places. Maybe I should figure out what it does. VL2. Bind to edit. Okay, so basically, does it allow you to edit the texture without binding it? I guess is how that works. So it's just saying internally, it may bind it if it needs to. Okay. All right, I think I have a pretty good feel for what's going on here. I think, well, yeah, so after we leave the scope of the constructor here, we're still holding onto the texture, but the image is going to go out of scope, so it must have copied it to the graphics card here, right? Okay. But we're holding on to this texture handle. So that we can render it. Okay. That was a bit of a dive there, but we got through that block of code. We're learning, it's fine. So we get all the way into the drawing function. So the drawing function, again, is fairly simple. We clear the buffer, set the base color, set the texture, and perform the drawing. And then we swap the buffers. So we clear the default frame buffer to our default color, which we set up here. We're going to need our math literals namespace inside here, it looks like. Where'd we go? And we're going to use our shader to draw the mesh, but before we draw, we're going to set the uniforms, and these are the ones that we defined here in our texture triangle shader. We're setting the color uniform, we're binding the texture to our texture. The color that we're setting here, we'll try out this one first, and then I'll try changing it just to see how that affects the output that we're drawing. Actually, what I'm going to do is, let's save this first here. What I want to do is I want to, oh no, because then I'll have to set up the mouse callbacks. I was going to do the same thing that the last example did, where you have a huge hue saturation value color, and you just like add 50 to it, so it cycles through colors on every click. Maybe I'll do that as a secondary step just to demonstrate how the color works there, or I might just recompile every time. Okay, so we're drawing using the shader, swap the buffers, and then we're done. Now we need to fix CMake here to use the resource loading and everything. So we're making a resources.conf file, which lists the resources which need to be compiled into the executable. So all of the shader sources and the texture image. Stone.tga. I think I'm going to need this probably here. Just downloaded it, okay. I'll just throw it in source for now. Yeah, because it expects it to be inside of there. All resource groups need to have a unique identifier by which they're accessed, so we'll use texture triangle data as above. Resource compilation process is explained thoroughly here. Okay, so we'll steal this. And again, I'm just going to put it in the same directory for convenience. But this would look different if I was doing something more real. In CMake lists, first we find the required Magnum package, now asking for trade library as well. I still am not quite sure what this trade thing is. Is it specifically plugin management? It's plugins plus the actual like image interfaces and everything also, and importers and everything. That's all within this trade namespace. No, the plugin manager is not in this namespace. Plugin manager is just a Magnum plugin manager. Okay, so trade is specifically all of these like sort of industry standard formats and stuff. Okay, so when we install Magnum, or when we request it rather, we're going to want trade. Do we not need shaders anymore? I would think that this abstract shader thing would be in the shaders library, but maybe it's not. Maybe shaders is only built-in shaders. Now we use Karad add resource macro and create an executable from the result and other source files. And then we link everything together. Plugin is loaded dynamically, so you don't put it in CMake. Okay, so this one I'm going to put under the source CMake list since it's relative to here. It's also more tied directly to this implementation. Texture triangle resources, resources conf. Add executable. We'll still just call it engine 132. So we need to add in our I don't think you actually need to add in the header as a source file, but it does tell CMake that if the file changes that it should how does that work? No, it's if the list of source files changes at all, then CMake knows to rerun. But I don't think you have to actually list it out in the sources here, other than it puts it in, like, if you're looking at this in Visual Studio, for example, then it puts it in the list of source files. I think that's all it does, though, for header files, because it doesn't need to, like, link them together or anything. We just include it up here, and then it should just work. I put everything in the header. I didn't make a CPP file for that. And then the resources. So this variable that this macro defines, we have to link to those also. Now we're linking to application GL Magnum trade, enabling additional Magnum components. Let's see what this is. If you're using the CMake subproject described in getting started, you need to modify the top level CMake list to enable the TGA importer plugin as well. So I probably will need to do this. Because the plugins are loaded at runtime, CMake doesn't know we need them to be built. One option is to list them explicitly. Another uglier option is to not use exclude from all on the Magnum subdirectory, so everything is always built. Plugin modules are placed into there in the build directory, and the trade library will find them there on its own. Okay. So with TGA importer, we're enabling add dependencies that one will go in here because we need a target. Is it not called target add dependencies? Add dependencies, target. Okay. CMake is not consistent with its naming conventions at all. This is called example, or no, engine Magnum TGA importer. Okay, so now CMake knows that when engine is built, TGA importer must also have been built before. If you're using a Magnum package, TGA importer is included by default, and you don't need to do anything in CMake in order to use it. If you build it yourself, make sure you have with, yeah. Once the application builds and starts, you can now start playing around with the shader source, modifying texture coordinates or adding other effects. The full file content is linked below. Full source code is there. Ports branch contains additional patches that aren't present in master in order to keep the example code as simple as possible. Okay. So this example is not quite cross-platform, I guess because it maybe uses some OpenGL features that are maybe not available in these other contexts or something like that. PNG, JPEG, and other file formats. TGA importer is built in, but you can enable additional plugins. Trade abstract importer, any image importer. Oh, so there's actually an any image importer plugin that just handles everything, I guess. That's pretty cool. Does that mean you have to have every plugin already available? Probably. Or at least at any ones that you use at runtime need to be available, I'm sure. Enabling Magnum plugins in your project. If you're using subproject shows up in the getting started guide, you need to modify blah blah blah. Same thing that we just went through. Add Magnum plugins as a subdirectory and enable the new plugins. STB image importer is a universal dependency-less plugin that can handle common files. Okay, so Magnum plugins is a separate project, so you would add it like a similar to how we did Magnum and Corad. It would be an external Git submodule that you would include in CMake and tell it to build as part of the full build here. And then you can just enable them in CMake like normal. Any image importer and STB image importer. So STB image does all of these formats. Does any image importer do more than that? Yes, it does. Ooh, look at these. Basis, ICO, soft image, Photoshop, TIFF. This is Photoshop. Okay. Yeah, so the STB looks like maybe a nice middle ground. Or maybe I'll just do them all explicitly. I don't know. I don't think I'll go through this because it's pretty straightforward. TGA is fine for this example, and maybe in the next tutorial, we might have to do something like this anyway, so no point in going through that extra work there. So let's see if this all compiles, because I think we're at a point where it is mostly done here. Okay, so far so good. TGA importer was built. All right. Use of undefined type, Magnum GL version in Triangle Shader. Okay, so more includes that I forgot, it looks like. Okay, GL attribute, color. We need texture 2D. Could forward declare that, but I'll just include all these. This one. What else do we need? GL version. This one. GL version. GL shader type. Shader type. In here, what else do we have? GL shader, shader type, utility, Karad utility, resource, utility resource. Okay. Int, I'm hoping that one of these just includes int. Abstract shader program. All right, I think that's maybe it. Let's see. Ugh. Ugh. Not quite. Assert version supported macro not found. Yes. Can I wildcard here? You can omit any prefix from the symbol or file path. Tab autocompletes common prefix. You can copy a link to the result using keys that I don't have on my keyboard. Markdown link. Wow, that's really cool. Can I like star assert? assert GL version is supported. Where is this? Context.h? Didn't give me a nice little pound include guy. We're going to want this internal assert output thing too. Internal assert performs the call even if no assert is defined. Making it useful for checking function output. Internal assert condition. Okay, so that's an interesting use or interesting point to make, I guess, is that if you, when using asserts, you have to be careful that you're doing it correctly, because you can turn off asserts at build time, and if you do that, depending on how the assert macro is defined, you might end up not running code that you wanted to run. Like in this case, that's what this macro is for. Is run the code no matter what, and then only do the assert if assertions are enabled, as opposed to not running the code at all if assertions are disabled. I'm getting this. Assert. Okay. And then back in main, didn't we have another one of these? Crowd internal assert. We'll also need the assert there. Probably transitively included, but that's fine. Magnum GL shader compile. None of the two overloads could convert all of the argument types. Let's do like this. Actually, let's do like this. So on line 52 of our triangle shader, shader compile vert frag. Could be initializer list. Cannot convert from initializer list to std initializer list of Crod containers reference Magnum GL shader. No conversion from Magnum GL shader to a reference to GL shader. Runtime error is not a member of std, so I need to exception, including exception. I don't know why it can't figure out the types here. I think the typical Windows compiler being a little bit dumb situation. Let me get this set clear color thing. No conversion from Magnum GL shader to Crowd containers reference shader. So it's basically a std reference wrapper. Works on incomplete types. The constructor is implicit. So I would think that would work. Hmm. So I'm thinking I either need to fix this. I either need to mark this like explicitly like initializer list maybe. Of what is it? Rod containers reference Magnum. Well, actually, we already Magnum EL shader. That might help the compiler realize that it's supposed to be that type. Cannot convert. Still doesn't want to convert these individual ones. Okay, so maybe I do maybe I have to, I could like std cref. I don't know if this is a function or a type. I think it's a function actually. It is a function. I'll need to include this file. In order to try this out. So now this, including this, makes these Karad reference types implicitly convertible from the std reference types. So maybe by wrapping it in the std reference type easily, it'll convert. I'm only doing the std reference type just because it's shorter to type out than I think the Karad version will be. So let's see if that helps. Oh, I did the initializer list wrong. I think I missed the parentheses on that. Initializer list is unexpected in this context. Oops, I forgot the parentheses. Runtime error is not a member of std. Forgot exception in the other file. Magnum shader compile, none of the two overloads convert all the argument types. Could be this, while trying to match argument list to initializer list, but then it doesn't even say I mean, I got rid of the other error about could not convert. None of the two overloads could convert all the argument types. Let me try the initializer list one again, but with the actual correct syntax. It was an initializer list of rod what was it? Containers reference of GL shader. With an I need the actual parentheses around that, I believe. That goes away. This might still fail because of that trying to convert its thing. So, nope, that looks like that worked. Okay. Now main, did I not save? Did save. Include exception, runtime error is not a member of std in main. What? I'm including exception. Is it not in the exception header? Stood accept. Oh. Okay. Same over here then. So what's in the exception header then? Exception. Stood exception, but not stood runtime error. Okay, well, forgot that. All right, so I think this should compile. No! All right. Let's see. Plugin manager. None of the plugin search paths exists, and plugin directory was not set. Skipping plugin discovery. Plugin TGA importer was not found. Okay. So it's looking build vs bin Magnum D importers. Bin let's see if I can actually hold on. Which find? Oh no, it's the Windows find. I don't know how to use that one. Where do I install? Where do I install the GNU tools? Program files. GNU Win32 bin find. name. What's it looking for? It's looking for importers. Importers. And it's a directory. Nothing. Okay. So I think that means something with my CMake is messed up. So we have with TJ importer on. We added TJ importer as a dependency to engine. Can I, okay, so one thing I can do is I can open up the Visual Studio solution here, and we'll just see what all of the targets are. And I would expect to see a target for TGA importer, I think. It's a little bit weird since it's just a dependency and not a target that I've added to CMake. So I'm not 100% sure of that, whether that will work or not. Oof. Yay. Yeah, so I'm expecting it to build the plugin into one of those importers directories. Oh, that's interesting. So we have our resources actually show up as a target here. Engine, we've got Magnum. These are files, but I'm looking for TGA importer. All right. Don't. Oh my God. Okay. um. I'm not sure exactly what this reference actually represents exactly, but the fact that it's listed here means it's at least seems to be at least a dependency to engine. Why? Builder. Hmm. So let's see. Let me just try. Let me build again to see what the error is. Because I already lost it here. Or wait, no, it's a runtime error. We see TGA importer built. It goes into TGA importer DLL. I don't see any importers directory, so I'm wondering why it's Why is it looking there? Magnum D importers. Let's look at the docs for this importer stuff. Hmm. Oh, it doesn't. It's actually really short. I'm looking for maybe the plugin docs would be better. Rod add plugin. Rod add resource. Did I miss something where I TJ importer? Did I miss a line on setting that up? I've been skipping out on this Karad piece because I haven't needed it yet, but maybe I should add that just to be sure that it's not that. Um, Rod add resource. On the executable, it's not explicitly Win32, but that shouldn't matter because that should be automatically deduced. Win32, if Win32 is given the property Win32 executable, we set on the target created. See documentation for details. That shouldn't matter. Need to modify the top level sequence list to enable the TJ importer plugin. The plugin modules are placed into this directory, debug bin Magnum D importers on Windows, in the build directory. Bin Magnum D importers. Debug bin Magnum D importers. The DLL is right there though. Maybe I just override the importer directory because it seems like it's not placing it into that directory like it says it should. This is perhaps a Magnum bug. So it did say plugin directory was not set. Plugin manager. Let me just try this. Is plugin manager part of Karad maybe? Yes. Oh, I forgot to also add Karad main here. Which again, I don't think I need, but they do have it in their example, so just to be safe. Now, I wonder why I didn't need to add plugin manager. main. Doesn't even really say what main is used for. Plugin management, path. So you can set the paths per plugin, but I don't want to. I shouldn't need to make my own plugin for this. Meant to be used to implement plugin search paths. Plugin directories. If a non-empty plugin directory is passed to manager constructor, okay, this is what I was looking for. I can override the plugin directory. Okay, let me just try this. Utility directory executable location. Ooh. Is prepended to relative paths before testing. Okay. So I think that means if a non-empty plugin directory was passed to this, plugins are searched there, but it's relative to executable location. So since it looks like it's putting them right next to the executable, right, in bin. I don't know, when it says non-empty, what type is this thing? Just a SID string, so empty string is the null case. Yeah, so I think I do need a dot. Okay, so it actually didn't like having the Karad build in CMake here. Find package Karad. I would have had to do the CMake module path thing again. Yeah, I shouldn't need to do this because clearly the plugin loader, the plugin manager is fine. It's rather it's able to like instantiate the plugin loader and everything. It's when it's trying to load the plugin from that it's failing. So the problem is not with Karad being not linked or anything like that. It's something else. Okay. TGA importer is not static and was not found in dot. let's try. Let me just print out the executable location right before we try to load the plugin. This is a stood string. And I need to include the thing that contains that. I'm kind of surprised that this didn't work. binengine.exe. Also, it's actually the path to the full executable. Not just the directory that it's in. Preprinted the relative paths. Okay, let me just try an absolute path. I'm using a raw string literal here, so these backslash escapes don't mangle the path. Okay. Nope. Gotta rebuild. And that worked. Okay. That worked. So that means that it's some problem with Magnum when it's building the TGA importer plugin, putting it in the wrong directory. Code cycle engine build bsbin engine. Yeah, so it was looking in where was it looking? Bin Magnum D importers, and then a relative Magnum D importers. So why did it not build it into that directory? Plugin compilation. Now, this is how I make my own plugins, but this is not how to hmm. So we say with TJ importer on before we add Magnum. I wonder if I need to do that before I add Karad instead. No, because again, it definitely built the TJ importer plugin. Because we saw that in the logs, in the build logs. It's simply that where it built it seems incorrect. Importers. Let me just see if there's any GitHub issues around this. Importers. No, these are just things to work on. Importers directory. There's no Magnum importers folder around my executable in the build directory. And it looks like this guy's also setting it explicitly. Expected directory structure for plugins is created once you install the project to some location. Make install an equivalent. Load the plugin by passing the whole path. Switch to static plugins. Magnum plugins repository. Does it make sense to have the plugins in a subdirectory within the build directory without installing for local development? I think it does, because it searches both the build, it searches relative to the executable and then also relative to the working directory. So it doesn't seem like I need to do this install step. Hmm. Magnum plugins dir. I'm wondering if most of them depend on install dir. Magnum plugins include install prefix. I'm trying to figure out whether I'm doing something incorrect or whether this is just a bug in Magnum. Importers. Magnum plugins. Blank install dir. Magnum plugins install dir. Install prefix. Well, this is even a different directory, though. Magnum plugins. Oh, I misread this here. Magnum plugins debug binary install dir is the Magnum binary install dir / Magnum D binary install dir bin. Where does it set up the install target? Plugins debug dir. I don't see the. Maybe it's in the subdirectory. But it does seem to agree with what that guy said, where this thing, this Magnum D subdirectory under build, is only when you're installing, not when you're doing just regular builds. And considering that when I pass a path to the plugin manager, it overrides the default search paths, which I don't really like. It seems like this should work if I'm in an installed context. It's just that when I'm building locally, that doesn't work. I didn't mention this in this bit, because not only do I have to tell Magnum to build TGA importer and tell it that it's a dependency of my project, my main target, it also changes where it's built into. TGA. Debug installers and release installers. set target properties. If CMake runtime output directory and CMake library output directory and CMake archive output directory. CMake is the best kappa, I guess. Yes, the kappa is appropriate there. Set target properties, runtime output directory, CMake runtime output directory. I'm wondering if like maybe this is supposed to, I can't remember what these properties do. Runtime output directory. The directory into which runtime target files should be built. That seems right. That seems like that's what it should be using, but only if these are set. And they're maybe not set because these are, one of these are unset, perhaps? So I'm going to try printing these, I guess right before it gets into Magnum CMake stuff. And maybe I'll also do it right before I build my target, because that's where the well, I guess it's all at configure time, so that's not gonna matter. Yeah, let's just see what this gives us. Oh. Runtime output directory, library output directory, archive output directory. Those are all set. So therefore, when I'm building TGA importer, these properties should be set. So it should put them into these directories, and it's not doing that. Can I do a get target property maybe to check? And where is this going to be? After we add Magnum subdirectory, maybe like this. The target is Magnum TGA importer, and the property is CMake runtime output directory, and then library. I like how these line up. Archive, and then we want to print these. Not found. Okay. But it found the target, right? Like, what if I give a fake target here? Is it gonna show up as a not found variable, or is it gonna blow up CMake? Blows up CMake. Okay, so it definitely is finding the Magnum TJ importer target, but this property is not set. Even though I'm seeing in the source code here that it should set the properties. Am I insane? Is it possible that it's not actually getting in here, and maybe it add library? No, it's right here. It's right there. "14 months ago, this was added, so I'm pretty sure I have it in my local copy. I should, right? External Magnum, source Magnum plugins, TGA, CMake lists. Yes, it is set there. Okay, well let me go back to that actually. Oh, I already just killed the buffer. Thank you. External Magnum, source, plugins, TGA, importer, CMake lists. So I'm just gonna get some messages in here. Message. Uppercase that just so I can see it. So maybe adding properties, and then definitely adding properties, and then I'll also print out the value of these things. Maybe like this. So we should be able to see exactly the values that it's getting at that time. Maybe they're getting unset somehow. Maybe adding properties. It is set, it is set, it is set. Adding properties. What? So it is adding them. TGA importer. Okay. Maybe TGA importer is different than Magnum TGA importer. How does that work? Add plugin. Try deleting that. Not found. Stored in the variable var, right? I'm not misusing this. Target properties not found. We set to bar not found. Yeah, okay. Okay, so it's definitely getting in here. Setting these properties. Magnum TGA importer target alias for super products. So I'm not actually familiar at all with CMake add plugin. Okay, so this must be a custom thing. Maybe? Rod add plugin. Macro add plugin. Which is Karad add plugin, set target properties. And that's it. Karad add plugin name. It's going to be probably in here somewhere. Come on. Oh my gosh, come on. Here we go. So, plugin name, Karad target windows. So there should be a library target called plugin name, where plugin name is TJ importer. So I'm wondering, how does this actually work? Where you say add library, this one, alias to this one. That's not overwriting. That is literally just creating an alias, right? Alias libraries. Creates an alias target. Target may not be an alias. Yeah, so both of these should be available. Why? I see that it's getting in here, set target properties, and then by the time I'm out here, it's not set. Maybe I was wrong with my directory assumption here. So what if I put it at the... Well, let me try putting it at the very end of everything. After I've processed my source directory, I don't think this is going to change anything. Not found. CMake runtime output directory. Target properties aren't limited to directory scope in CMake. I'm 99.9% sure. Property, oh my gosh, okay. Here we go. Runtime output directory is not the same as CMake runtime output directory. So I have a typo up here. We're getting the property called that. Okay, so copy paste error on my part. Okay, so it does set the runtime output directory to that. So that is what I expect. And then it builds it, and it doesn't observe that. Hello? Okay, well at least I'm not entirely insane. It did get into this place. It did set the properties. Runtime output directory. And is Visual Studio just completely ignoring these? CMake runtime output directory on Windows. Uh-oh. Linux, it works fine. Windows, they can place into debug relate. Well, yeah, I expected that. Mm, no. Multi-configuration generators append a per-configuration subdirectory unless a generator expression is used, and it is using a generator expression here. Hmm. Um, so why does it seem to be completely ignoring this? It's not just that it's making debug release subdirectories. Let me like triple check my directory structure here. Where was I looking? We were looking in bin Magnum D importers or current directory Magnum D importers. Oh. That's right. I hope I have tree in here. I do. Bin. There's no subdirectories under bin. Why shouldn't I have debugger release? I don't know why those aren't there. That's not particularly useful. Source, not source. Recipe. TJ importer DL just goes straight into bin. It's like it's ignoring that property. And that's it. Those are the only DLLs. All DLLs end up in bin instead of lib. config, and config. Hmm. So maybe this is being set and it, does that override the property? No, it seems like it, oh, but it uses it to initialize this property, and if it's set, I think this overrides, so that's possible. So let's see if debug is set. And then let's also see if there's a debug property set. Sort of, it's maybe a bit of a stretch here. Ah, it is set. It is set, and therefore it's overriding. Yep, look at this. Look at this. Yeah, it's overriding it. Hello? So who's setting this? Are they setting it, or am I setting it somewhere? Or is it just defaulted? Um, new in 3.3. Can I just unset it, maybe? Let me check. Let me just grep in here for cmake runtime output directory debug. Only my debug print right there. So they're not setting it. I'm just getting it by default, it seems. Can I? Is it correct to unset it like that? Add the extra debug release. I'm trying to figure out whether this is, because this still could be a Magnum bug. Like, should Magnum be accounting for these special directories? Should it be using the like runtime output directory debug here instead of checking the config in the generator? Or is it my responsibility to like not be setting those? Um, I'm not sure. Like, what's going to happen if I unset these things? Is that the correct thing to do? I don't want this to be a hack. I'm not sure this is correct, but I'm going to at least try it out. Oops. Definitely feels like a hack. Okay, so now these are not found. TGA importer got put into the correct directory. Okay, so that's definitely the problem, 100%. I don't know what the correct solution is. Why are these set to the same values? Let me put these up before the unset so we can see what they look like again. Why are these set to the same outputs? What am I trying to say? The directory is the same regardless of the configuration, which is not how I thought. Since Visual Studio is like it's a multi-configuration compiler, is I think what CMake calls it. It normally puts a subdirectory under your build directory for debug or release. Maybe it's because I'm using maybe it's because I'm using CMake -- build as opposed to invoking the Visual Studio compiler directly. Like maybe when you do CMake -- build, it sets these variables to make it more like a traditional single configuration build. Is that possible? That seems reasonable. Yeah, so now it's setting these to both the same. Oh. Okay, so what if let me try a new build where I'm only doing it from Visual Studio. From the root. Okay, let's wait for this. I'm starting to lean towards I think this is a Magnum bug because it's not handling the possibility that a client is setting these variables. I should be able to set these to whatever I want, and it shouldn't break Magnum's plugin importing, is my thought. I forgot to run Conan install. Still do debug profile. Okay. Well, those are still set to the same things. Okay. It's a per configuration version of that property, but multi-configuration generators Do not append a per configuration subdirectory to the specified directory. Property is initialized with the value of the CMake runtime output directory config variable if it is set when a target is created. I just don't know where this is coming from. Who is setting this variable? Because I'm pretty sure if it's not set, well, is this true? We have a build here. Well, well, I guess it could still put things under subdirectories. I guess my earlier theory could still happen, although based on what the documentation said, I don't think that's right. Let me just try this. We'll build engine and see where it puts stuff. Ah, that's not what I wanted. Grab. Bin. Yeah, I would have expected a bin debug or bin release. Okay, so yeah, this is what's confusing me is every time I've done a Visual Studio build, it's always had those subdirectories under the build directory, and now it doesn't have those. And I don't know what has changed since the last time I've built with Visual Studio. Other than my CMake version is newer, my Visual Studio version is newer. Is this just the new way that Visual Studio works, or is it specifically because those runtime output, debug release variables are set in CMake? It's probably because those variables are set, and then that means the question is, why are they set? Who is setting them? Hmm. Debugging CMake is always a joy. Uh, CMake dash dash trace and dash dash trace expand. Variable watch. Ooh, thank you. Thank you. Excellent. All right. Okay, that's gonna help. And for some reason, I feel like can I put it at the very top, or is it gonna yell at me? 'Cause I didn't set the other ones first. I feel like it's just gonna be there by default, which would be surprising to me, but also I don't know who else would be setting it. Runtime output directory debug. Okay. We can just reuse this one. Excellent. All right, this is good to know. This trace variable watch. All right, so here's where we start. Variable was accessed using modified access with value in Conan. Conan! Oh, you ass! All right. So Conan, Conan is being a bad boy. Runtime output directory debug. How do I make Conan not do this? So it's a combination of I do think Magnum is handling this incorrectly. So I might have to submit a bug report to them. Because, again, I should be able to set these without it completely breaking the plugin stuff in Magnum. CMake multi-generator uses the same bin directory for all targets. CMake multi-generator. Conan build info multi. So Conan, maybe I shouldn't be using Conan basic setup. Let's make sure Conan is in the search. CMake multi. Conan output DIR's setup. Right, that makes sense for if you're writing a Conan package, but I'm not doing that, so why would it do that for me? Use all the macros below. No output DIRs. Okay. Options, no output DIRs. So I think I would say set no output DIRs true. Force. Not at the command line. Okay, so no force, I guess. Okay, so rather than, okay, we're not unsetting. And we want to take the trace off here. Those are still set. Conan adjusting output directory. So that's, why did that not work? No output DIRs. Am I doing something wrong here? Oh, is this CMake macro options? Is it actually a way that you put it in the macro? Set options. Set options. And then it's CMake parse arguments. Ah, okay, yeah, so I have to say this. No output DIRs. I see a debug in there. Importers, yep, okay. I think this is going to work now. Let's take this off here. Rebuild, so no path specified to the manager. And it looks like that puts it in the correct location there. And it works. All right. that was frustrating. Okay, so it's a combination of Conan hijacking output directories and Magnum making assumptions that no one is hijacking output directories. Okay, so what do I want to do? I think I do want to submit a bug report to Magnum. I guess I'll just do it. We're already 4 hours into this one example, so that's, I was really hoping to get a little bit more progress. I think this one, he had a similar problem, so I might mention this in the issue that I make. Let's just look for CMake output directory. Initial build experience frustrating and Conan package. That's interesting. My initial build experience was not bad at all. Oh my gosh, look at all this. Oh, maybe this is him building Magnum standalone? Well, I mean, I'm building Magnum too. I guess I'm not building every single component. Well, this is not relevant to what I'm doing. Conan package. And this is not... do I still have the link to the source code for that? No. Although this guy mentioned it. Now GitHub's doing this thing again where it hangs, or it doesn't render the page. I guess it's Chrome because I didn't refresh that page. Okay, so what am I going to want here for this bug report? We want probably one of these. I'll say this one. So I'll link to this one. I will, let's find the place in the source code where it's broken so I can point them straight to that. Magnum plugins. I wonder, they all have to do this thing, I bet. And then I'll link to this one, and then that's probably good enough. I don't have a template. So I've submitted some bug reports to various open source projects in the past. They usually all have their own sort of template for like what kind of things they're looking for. It's usually you'll want to put like environment info, so like whether you're on Windows or Linux, what compiler you're using, any kind of things like that so they can reproduce the problem. They want ideally an example that they can copy paste and compile that reproduces the problem. I don't know if I really want to go through that since I don't know. I feel bad not doing that because I know if I were on the receiving end of such a bug report, I would really appreciate it. But it's also just, it just takes kind of a long time. And you could argue that I already have something here, but this is a little bit bigger than the example needs to be. I think what I'm going to do is just say start with, start with the getting started example, because that's essentially what I'm doing is I'm walking through the examples here. Add in a line that is, these things, setting these variables. And I am quite confident that that would reproduce the bug. I'm not going to be able to, if I don't create a full example, then I'm not going to actually test that, but that's what I'll do for now. If they come back and ask for a concrete example, then I will put that together for them, but I'm not going to do it because I think it is very easy to reproduce if they already have an example ready to go. And I think the examples page even had like a zip that you could, just unzip. So I think that's what I'm going to do. So let's do like, I think that gives you a header. What's my, oh, that's the wrong one. Is there a, how do you get the Windows version? Well, maybe it doesn't matter. Visual Studio, what are we on here? (16.8.2), which is compiler version. I think I can do it from the command line here. This is the compiler version. Version of Magnum that I'm on, which I just did a git submodule, so probably just going to be a commit, a commit hash. We are on master, but there are more commits on top of that, so I'll just give him the commit hash here. It's only 6 days old, so I don't know what's a good way to specify this. The full SHA-1. Does it have to be the full one? I guess it doesn't hurt. So let's get the full hash that we're on. Come on. Git on Windows is unbearably slow sometimes. Holy crap. Here, we'll do it from here. Say git show. Thank you. So this is our Magnum commit. Magnum at that. Something like this, maybe. Oh, geez, finally loaded over here. Git show. So we're on this version. Let's see this. Oh no, it's not linking. Have to do like this. There we go. Nice. Okay, that works. What else is relevant to this? CMake version, probably, since it is a CMake thing. And we're on CMake version 3.18.1. And okay, I think that's good. We'll say, what is the title of this? Plugin import breaks if CMake. Where'd my music go? CMake star output directory star output directory star is set. So other things that you would usually put in a bug report is a description of the issue, the actual behavior versus the expected behavior, how to reproduce it, and then sometimes I'll put in extra stuff like how I think it should be fixed, like links to the code, the relevant code, those sorts of things. So we'll do problem. I don't know. And actually, we should probably give a. Oh, actually, now that we have a. Let's reset that. Now that we have a working example, I can explicitly do the thing that I was saying I could do to reproduce this. I'm not speaking very well, but I can set these variables. So the one that matters for a DLL is going to be runtime. And actually, that's probably the only one that matters. You go to blame. Magnum D. So the DLL is, I think, the only one that matters. Bin. Yeah, I think runtime is the only one that matters. Runtime. So I should be able to reproduce this by saying set CMake runtime output directory debug to just the CMake runtime output directory. that. What's our original runtime output directory? Because the bug is, if this variable is set, it is used to initialize this property, which overrides the property that they're overriding. Yeah, so I think this one line, I think, is all that we would need to reproduce. So let's try that. And now, by doing so, assuming this works, then we will also get the error message that it spits out, which is a good thing to include. Oops. So we built, we run, oh, that still works. Okay. Did it actually? Oh, because I need to do a clean build here. I already have Visual Studio open. Let me just clean. I think I can just clean, right? Clean. TJ importer. Okay. Let's try that again. Go ahead and paste that in there because I think I'm going to need it. It's going to take a little bit longer since it was a clean build. So say cmake runtime output directory is set. Importing a resource via a plugin will fail. I'll elaborate on that. It's still going. Here's where I would probably put the error. I think this is the syntax. Yes. Still going. So I'll put the error output here. And then I'll say as described here. If cmake runtime output directory config. Is there a better way to? Well, I guess that makes sense. That's how cmake describes it. Are we done? We are done. Let's see if that worked. Hello? Didn't even get a window. That's building more things. Okay. So we'll copy this line off. Example. mangle this a little bit, just because they don't care about some of those details. Okay, so as described here, if this variable is set, it is used to initialize the runtime output directory. I'll link that on output directory config property of each target. This property takes precedence over the runtime output directory property. This copy permalink means that the overrides, the output directory overrides set in each plugin CMake lists. The output directory overrides set in each plugin CMake lists end up becoming overridden themselves. That's kind of a dumb way to say that. Here I'll link to an example. So the plugin library cannot, will not be built into the expected location. Causing it to fail to load at runtime. This is a run-on, but this means that the output directory overrides the output directories that are set in each plugin CMake lists end up being overridden causes the plugin library to not be built into the expected location, causing it to fail to load at runtime. I guess that makes sense. starting with adding line to CMake before subdirectory. Actually, it's not importing a resource, it's actually trying to load the plugin. I'll just say plugins. Trying to load plugins will fail for example error message. Wasn't that error message is not quite the same. Because last time the error message had a list of locations that it was checking. I don't know why this is not working on my command line here. Maybe do I still have it in my scroll back? It's way back here. None of the plugin search paths exists, and plugin directory is not set. Why did that not give me that same error this time? Oh, bin engine. That's why it's not working. It's because there is no bin engine. Copy this off for my own reference, if nothing else. I'm not sure if this makes sense with my example, but could be useful. So what, none of the plugin search paths exist. Bin and importers. So maybe Maybe that does use the artifact dir instead of the like runtime dir. That's probably true. Oh wait, artifact? No, archive. So just for the sake of having the full error message, maybe it's slightly more useful to put all three. No? Oh well, again, I didn't do a clean build. Let's just remove debug. It would have looked like this. It's a little bit gross to mangle it like that in case I get a typo or something, but it should be obvious enough from that. There we go. Okay, so that's the error message that I'm expecting here. I'll just copy and make sure we've got the right text here. Didn't get the full. Oh. Why didn't it give me the full text here? Is it because it's I don't know. Why is it doing that? Not found in blank. Well, I guess we'll give them the full text even though it's incomplete. And again, we'll okay. So before whatever does this only apply if you're compiling Magnum as a subdirectory? I mean, obviously, if you compile everything Magnum separately and install it, these things shouldn't be set in the first place. Um, realistically, probably happen when building Magnum as a sub-project. Does one of the examples describe this? So yeah, as in example 1a. And then add the following line to CMake before add subdirectory Magnum. It is Magnum, right? It's not Karad. Yeah, it's Magnum. Do both debug and release, just so that no matter what they want to use, it should still work. I'll just say build Magnum as a subproject. As an example 1a, of the getting started guide, and find lines to make before add subdirectory Magnum. Build build with some plugin enabled and plugin at runtime, I guess. I'm starting to get really hungry and losing my train of thought. If CMake runtime output directory config is set, trying to load plugins will fail. Example error message. As described here, if this variable is set, it is used to initialize the runtime output directory config property of each target. This property takes precedence over the runtime output directory property. This means that the output directories that are set in each plugin CMake lists end up being overridden. This causes the plugin library to not be built into the expected location, causing it to fail to load at runtime. I'll say, as a workaround, well, no, that's obvious from looking at the docs. To reproduce, build Magnum as a subproject as an example 1a of the Getting Started guide. Add the following lines to CMake before add subdirectory Magnum. Then build with some plugin enabled and try to load the plugin at runtime. Okay. Plug-in import breaks if that's set. Should I add a possible fix? The possible fix would be in each CMake lists you handle those if they're set. I'm trying to decide now if I don't think I'm going to put a potential fix because I think it's obvious from looking at the CMake list's current thing that it would be basically exactly the same. But I am thinking about putting a note about Conan. Um, Probably put this as a second comment because it's not relevant to the actual problem here. But for future users, in case they run into the exact same issue, it might be a useful thing to note. All right, so I think that's good. And then I'll say just as a note, in my case, reason this variable set of I'll say in my case this was I ran into this because of Conan. This isn't quite what I'm trying to say. In my case, I ran into this because of Conan. By default, Conan basic setup. Modifies build output directories by setting these CMake variables. I switched to using this to avoid this behavior. Just as a note, in my case, I ran into this because of Conan. By default, Conan basic setup modifies the build-up of directories by setting the CMake variables. I switched to using Conan basic default notes to avoid this behavior. Okay. So now if anyone comes across this issue in the future, hopefully that'll save them a couple hours of debugging. All right, I think we're done. All right, now let's clean this up and commit it and get some dinner. Let's see, all these are gone. Was there anything else? I did want to try out a couple of things, but I'm kind of tired at this point. Let me clean up some of the debug stuff. Don't need that. Don't need this. Interestingly, we didn't get to this thing, I think. Or maybe we did, and I didn't see the runtime error, but it might have aborted before that point. All right, that all seems good. Don't need this utility directory bit. Okay, and then I do want to comment on here. When default sets CMake run time, or actually no, it's CMake star output tory config variables. Which breaks Magnum's plugin. Oh well. Which causes Magnum's plugin import to fail because the plugin library gets built into a non-default directory. And then I'll put a link to the issue so I don't forget. Running by default sets CMake input to fail because the plugin library gets built into a non-default directory. Using no output ditters to skip this behavior. Okay. All right, let's scan over all of this. All right, let's get rid of this variable watch with TGA importer, match tools and primitives and shaders, dependency. We added shaders. We added this. No extra comments or anything. That's done. I'm pretty much just looking for any like temporary code that I left in place, which I don't see any. Don't see any resources, and then that. Interestingly, one doesn't matter in this case since it's. I don't think it matters in this case since it's so small, but resources, binary files in general in Git can be annoying. Not just their usage, but because when you clone a repository, you end up getting all of the deltas since the beginning of time for that repository. Unless you opt out of them, you have to add an extra command line argument to only do a certain depth or something like that. So that ends up, if you check in binary files, they then become part of the Git history forever, which can slow down cloning. And this one is probably so small that, I mean, well, it's 256 by 256, so not realistically not a big deal, but in general, or especially once it starts getting bigger, I might want to put resources in a submodule or something like that, so that they don't, so that you can avoid cloning them unless you really want them, I guess. You still will need to clone them at some point if you're doing stuff, but I guess, so for things like the stone texture, that's not going to be in the final engine or anything, so having it in the history is sort of pointless. Yeah, I guess really the problem is not that it's not checking in resources per se, it's more checking in resources and then removing them, checking in big binary files and then removing them later, and then they're now all of a sudden part of your history forever. Obviously, in order to build your code, if you need those resources, then there's no point in really separating them. But if you were to make a lot of changes to them, that could cause Git to become really slow. I wonder if there's a way to, if I were to set it up as a submodule, can I like request in the Git, what is it, Git modules? Can I say like a default depth? Because that would sort of fix that. If you have your resources in a submodule and then you by default only clone, the recent 100 changes or something, so you don't have to worry about all of time. I don't know. I'm, once again, tangent that doesn't matter now. Update example to draw a textured triangle. Let's recompile this to make sure that I haven't completely broken everything. Oh, can't delete it while Visual Studio is open, of course. Ideally, I should be doing a clean build here because it's going to leave a bunch of stuff around, but that would also take a while. Oh, boy. I'm kind of really curious what this looks like. What? doesn't it like that? Yeah, just a bunch of buffers, some CRUD stuff. Ooh, yeah, look at that. On the resource initializers, resource.count, resource.positions. Oh, count is the number of resources. It's not because it's a triangle. Okay, anyway, that was fun excursion. Okay, so still compiling. I have not broken everything. Push it. All right, I think that's where I'm going to call it tonight. It's unfortunate that we spent so long debugging once again, but whoa, this guy already responded. Holy crap. All right, so he said, yeah, the plugins are expected to be in those particular subdirectories relative to the interface library. Otherwise, it's not really possible for the plugin manager to discover them or know which plugin is which. The library already decides based on presence value of CMake runtime output directory on its own. Isn't currently aware of the config. I'll have to fix that. Wow, man, this guy is awesome. That was such a fast response. Literally, what, 7 minutes? Man. Or I guess maybe 11 minutes from my first post, but that's crazy. That is some response time. All right, so that's cool. The fact that he responded so fast, at least, is again another makes me feel more confident about choosing Magnum. Obviously, he may not have the resources to fix it right away, and with their release cycle, you know, it might take a while, but it's not a dead project, I guess is what I'm getting at here. All right, so that's where we're at. We can get out of all of these. Let's close out of some of these. All right, so unfortunately only got through one example. Still need to do this last one here. Try to do that in the next couple of days. And then I have a couple of things that I personally am curious about. We already went through custom shaders, so that is one of the things I was curious about. There might be some extra things in this example. I want to try writing a custom loop, because right now it's all being driven by that Magnum application class. What else did I have? I don't remember. I'll have to go check my notes maybe. Overall, I am pretty happy with what I'm seeing so far. Really liking the design of Magnum so far. Like just all the code looks really solid. Obviously, it's got a couple bugs as we saw today. As long as I still think it's a net gain. In order to get a triangle drawing without using Magnum, it would have taken me probably multiple days. So even though we spent a couple hours digging into that bug and working around it, as long as it's a net time savings, it's still worth it. Now, can we generalize that and say that that's going to apply for all future, bugs that I might run into? I don't know. Really hard to say, obviously. I think it's likely that it would be a net time savings, just because there's so much, so much that really goes into, like resource loading and setting up OpenGL and everything. Like that would have been at least months getting to the point that I'm at, I think, to be able to draw a textured triangle or cube that rotates and changes colors. Like I think all of the setup for that, writing some of those supporting libraries, would have taken months. So I think that's a good sign. Obviously, I'm still going to try to, see if I can find any deal breakers, but I'm hoping that, within a couple more days of, go through this example, go through some of my own things I want to test. I think we can get through those in a couple days, and then get on to some actual engine design, and start working on the real thing instead of these toy projects, toy examples. So, all right, awesome. That's probably where I will leave it for tonight. So, thank you for watching. Hopefully you enjoyed, even though maybe you just enjoyed laughing at me, my suffering. That's totally fine. So, I guess that's it. So I'll see you guys later.